Greetings. This is a short lecture with a couple of simple examples related to test doubles and mocking as part of software engineering in practice. Uh, Test doubles and mocking relates a lot to unit testing that's done by programmers as they're creating software, but it could also be related to other types of software testing as part of the software development process. Test doubles and mocking is conceptually straightforward, but is highly technology dependent. So the way that it will be implemented would vary dramatically if you change from one programming language to another. The beginning starts with a little bit of a definition, and this sort of fun definition, as a test double is basically a pretend object used in place of a real object for testing purposes. So you take the real object, you substitute the pretend object, use the pretend object, then return back to the real object. This is a test double. And mocking is the job of fooling the real application that it's talking to the real object instead of the double. So it's mocking, it's pretending to be something else. We've used this type of technique in software engineering for years and years. The terminology has changed a lot. Right now, test mocking and test doubles are the terms that people use, but it's also been called test harnesses and test fixtures and testing hooks of different types, stubs and test harnesses, things that allow tests to run to basically trick the code that you're developing into believing it's running a real application when it's running a sort of pretend version of one, or an instance of one that has some elements that are fake. And I'm not saying we have to be crude about this. It's not trying to fake the universe and model everything. It's usually a very specific thing that we're going to be using this for. For example, if your application processes business transactions and takes credit cards, at some point in time, there's probably, for each transaction, a credit authentication check. A credit authentication check probably involves a remote procedure call to a service at your bank or financial institution or credit supplier. That remote process call, that call would probably be one of the slowest transactions that would take place and requires going through corporate firewalls, talking to real banks. It is actually a very expensive and time consuming and hard to orchestrate transaction during day by day development. So during day by day development, why not create a fake object, a pretend object that acts like the call for credit authentication, but runs locally and basically doesn't do a real credit authentication. It does a fictitious one, but it's good enough for the business logic to be thoroughly tested. Of course, at some time before we ship that software, we do have to test it with the real authentication service, but not every time we do a build during continuous integration. So this is where test doubles and mocking really has a fantastic benefit. Development teams want their continuous integration to run frequently and to run quickly. And so we don't really have the time to do these remote procedure calls every single time we do a build. And some companies do builds hundreds, if not thousands of times a day. And imagine if you pay money for each of these transactions, you might pay, I don't know, $1 every time that you get an authentication. Well, it might be thousands of dollars a day just to get fake authentications on external services, where you can all do it with a mock object that can be put together and written in no time flat, especially if it's done by the programmer who wrote the code that's being mocked. So this is a handy thing. Test doubles or mock objects, test doubles, have a lot of different things they can do. One thing you see is isolating units of code. So you can sort of say the separation between the business layer and the data layer could have some sort of API in the middle, which we could then put a mock object in so that would fake all of the calls to the database, which might be handy when you want to basically test algorithms that use data. You don't necessarily have to go to the database every time you want to run a regression test on that. Manage the order of calling. Some people find this very important. Mock objects are used for this purpose. I actually have never had to do that in my professional career, but I've seen it so often in transactions that are developed, and they want to look at the order of processing, and they use mock objects to help them with that. So the mock object would basically call the real object, but keep track of some state information in the middle, and then be able to report on the order of calling the real object without having to change the real object. Isolate third-party objects, that's like the credit card authentication software. And the last one in this list, isolate legacy code. I think it's really handy, especially if you've got a lot of legacy code. You just don't want to touch and muck with it. So you look and you sort of say, what if we put in points in the code, which are like the hook between our new code and our legacy code, and that API becomes something that isolates the legacy code from our code being developed, and perhaps then we can use the mocking to fake out the legacy code while we're developing the new code during our regression testing, if it makes sense. So this is types of things people do with mocking. Mocking fits all over the place in software engineering. So it's very, very handy during unit testing, and it's almost mandatory that we do some mocking when we're doing unit testing, because we're faking out stuff that's not there. Usually the programmer wants to focus on the requirement that's being implemented or the technology that's being implemented, and anything external to it that's not germane to the processing might be mocked. Why not? Just mock external stuff. So unit testing, very handy. Story testing, when you have external services, it's very handy. So if you have external services or objects that are running on different servers and you want it to run quickly, you might use a mock object for that. And then testing in the IDE, any testing you do in the IDE, whether it's automated or manual testing, you could put a mock object in any time and use that to help trace your code, help see what the state of the systems is. So basically mocking fits in a lot of different places, and it's not in this list, but some companies do something called integration testing. It would fit there. It would fit also in certain things, like, for example, if you do load testing and performance testing and you don't want to go to a real authentication server every time you want to authenticate a user, you might mock the authentication server so that when you do simulate millions and millions of users, you don't actually go and chalk up a real authentication server. Why mock? So a lot of reasons. One, stub code that doesn't exist yet. Hey, we're developing software. We're a team. It's not all ready. So if I have some code that I know is being developed, but it's not ready yet, I can create a mock version of it, a fake version. It doesn't really do the processing, but it returns what might be reasonable results. So totally fake, but useful for me. That's for code that doesn't exist. Of course, when the code comes into existence, then we'll get rid of the mock object and replace it with the real object. Simulate unavailable or expensive to access services. Simulate third-party objects that maybe we don't have, or we don't want to use the real one all the time. And then there's a cool thing we can do with mock objects is to simulate exceptions. A lot of type of exceptions that I see when I'm developing software. I say, okay, what if I don't have access to the file system? What if the file is corrupted? What if there's not enough memory? What if the network is down? What if the user doesn't have the right privileges? So all sorts of exception handling is it's a testable thing. Exception handling is a testable thing. And very often what you do is you simulate the exception, then you run the test, and you look at the results, and then you restore the system to a controlled state. Well, if you're using mock objects, you can actually just call the mock object instead of the real object and just generate the failure. So let's say the classic example for me is, what if you have a case where a file is too big? Well, a file is too big. Let's say you want a file that's 2 terabytes or bigger, and you realize how ridiculous it would be for you to try to create a file that's 2 terabytes long for the purpose of testing. I mean, it's an absurd long file. So instead, why not mock the object that opens the file and just have it return a size that says it's 2 terabytes and fake out that it was successful. Or another thing you might do, so you don't have to have the real thing. What if you want corrupt things? Why create a corrupt thing? Why not just fake out the error message saying, hey, the data is corrupt? So we basically can do all sorts of wonderful testing of exception handling gracefully using mock objects, simulating exceptions. Some people spy on process flow. I've seen this a lot in transactional financial software and insurance companies. I haven't done a lot of this myself personally, but I know what they do is they put in a mock object and keep track of the access to the real object and looking for things that might be called out of order or redundantly. Maybe you want to confirm that the parameters are in the range that are expected before you give them to the real object, so the mock object can do some error handling, which might not be needed in the commercial system, but is needed in the regression system. Firewalls, perhaps we want to avoid going through a firewall during integration, during continuous integration. Maybe we want to avoid incomplete integration paths of the code. So some of the code doesn't exist, so we want to fake out the path it's taking. And of course, one main reason why people like to mock things is to make things faster. The whole thing is we want to regress this faster. When we run our unit tests, we want it to take milliseconds or better. If it starts taking 50 seconds or 2 minutes to run a unit test, well, that's way too slow. So we might want to mock out the slow part of it and zip it up for the purposes of our continuous integration regression testing. So that's when mocking becomes really handy. How does someone mock? Well, in this day and age, of course, we have frameworks that exist, and you can acquire a mocking framework. It's added to your integrated development environment, and all modern integrated development environments support many different mocking frameworks, but you definitely got to get the right mocking framework for the right development environment, for the right programming language. In the source code of your unit tests, in the case that I'm talking about, or whatever test you're creating, in the source code, you would create a object, name it what you like. That's going to be your mock object. Make sure it's got similar and identical parameter types to the real object you're simulating, and then basically create code in the mock object to mimic the real object's behavior in any way that you're trying to simulate. Which means that if it's supposed to be returning valid data, return valid data, error conditions or exceptions, return error conditions, exceptions, do whatever you want to mimic the real behavior of the system. The tools for mocking are highly technology dependent. And the way you mock in Java is different than the way you mock in C#, and it's different from the way you mock in Swift, and it's different from the way you mock in Python. All these programming languages enable some sort of mocking, but the method you do to implement it is dramatically different for each technology stack. Many mocking tools, in fact, all of the ones that I've used in the last few years, are open source. That means you can access them and get them from the open source community. They're very well supported. They integrate with the IDEs gracefully. And they're just invoked using the unit test framework, the exact same framework you're using for your normal unit test creation. So JUnit would be perfect for creating mock objects for Java, for example. Now, I want to show you just a little example of a bit of mocking that I like to do here from time to time. So this is an example application that is inspired by the C programming language book by Kernighan and Ritchie, where they use an example. Throughout the book, they use elements of this example, and they have little exercises and assignments about this example. Basically, write a program that counts the number of lines in a file, a line counter. So I have a program here that I've created that counts lines. I've created it originally in C, and then there were versions of it created in Java, C++, JavaScript, Swift, and C#. There's all sorts of different versions of this program. And if I have to, I'll do other versions in other languages, because I use this to just show people about how unit testing and mocking can be implemented. So all this program does is basically, it opens a file. In fact, it's a fixed file, file.txt, opens the file and counts how many lines are in it. It does it by looping through, reading one line at a time and counting. And at the end, it reports the count. What is the count? The program does a little bit of exception handling. For example, what if the file's not there, or what if the file we don't have access to the file? So there's a couple of exceptions that we try to catch. But for the most part, it's just returning a positive integer for the count of the total number of lines in the file. Now, when we're testing this, we want to test all sorts of conditions. And some of the conditions we want to test are, well, let's say a file with a small number of lines, a large number of lines. You might want to catch a file with more than maxint lines. So if maxint is if maxint is a 32-bit signed number, it's something like 3.4 billion. So a file that has more than 3.4 billion lines, that's an absurd thing to imagine creating such a file. Of course, we could probably do it, but it would be slow, time-consuming, and laborious, and it would take a long time for the application to run, no matter how brilliant you are at optimizing your code. So that's an excellent opportunity to use a mock object to basically simulate the processing of the file. So the bit that we'd mock here is the procedure count line number. The application uses this procedure, right? So this procedure is what we would want to mock in certain exception cases. And we have here an example of mocking for a file that's, for example, very big. So if the file is very big, we'd basically, what is this? Have some sort of a return a big number. So return a big number. So big line file just returns a big number. Or these are not just objects. A big one returns a big number. Small one returns a small number. Negative one returns a negative. You can imagine, what if a file had a negative number of lines? Again, these are conditions that physically might not be possible. Also, we might have a mock object that would be included for the case of an I/O exception. So what if we had an I/O exception? So we'll simulate that with a mock object. And all of this, this whole program file here, which is, there's a copy of it in my course's examples under test-driven development. You'll see this. There's basically examples here of how you might use a mock object. In this case, the file I have opened is written in C#, but it could be, there's many other programming languages in there. As I said, I've got Java examples, JavaScript examples, Swift examples, and C# examples of 3 different programs using mock objects. And the idea here was, if you will, for example, let me see here. Which one do we want to try here? Test method for counts line number. Okay. Mocking this one. So in this case, what you do is, this is the test. This is the test here. And what we'll do is we'll say, okay, we want to basically test what happens if there's a small number. In this case, the line count perhaps would be 0. So we basically create a object, which is a mock. So this mock is a new mock of Rob's line count. And then what we do is we do some sort of initialization of it using the mock setup function. When we basically run our test, we say, okay, let's do the line count, right? Line count is equal to the mock object of count line number. In this case, that's going to be the small line file value that's going to be returned. And we can then assert how that matches with the actual line count. Now, where's the line count computed? I don't remember where that line count was computed. Here's the output of it, yeah. So this one here is the actual output. This is the output from the mock object, and the two, we'd expect them to be the same. So that's for too small, and you have similar things for negative files or for too large negative files, and as I said before, I/O exceptions. In either case, this is examples that are written in C#, but every programming language has its own mechanism, how to create the object, how to tell the software to use the mock object or to return back to the original object. And you'll see that well described in, of course, the literature, with tons of examples online for these different technologies. Anyhow, that's all I wanted to say about mock objects, and look forward to seeing you guys soon. Thank you very much. Have a great day.